The Sun is a massive, glowing sphere of hot gas at the center of our solar system, making up 99.8% of all its mass and weighing over 330,000 times more than Earth. It's a yellow dwarf star composed mostly of hydrogen, about 74%, and helium around 24%, with small traces of heavier elements. Despite being 93 million miles away, it's the reason we have light, warmth, weather, and life itself. At its core, the Sun reaches temperatures of 27 million degrees Fahrenheit, 15 million degrees Celsius, creating intense pressure that drives nuclear fusion where hydrogen atoms slam together to form helium, converting about 4 million tons of mass into pure energy every second through Einstein's E=mc. That energy takes tens of thousands of years to escape the dense core, but once it reaches the surface, it travels just 8 minutes to light up Earth. So when you feel sunlight on your skin, you're feeling the result of a mind-blowing process that's been burning for 4.6 billion years and will continue for billions more. But the Sun isn't just a static ball of fire, it's alive with activity. Its surface, called the photosphere, constantly shifts and boils with massive convection currents. Above that lies the chromosphere and the corona, the outermost layer, which surprisingly gets hotter the farther it is from the core, reaching over 1 million C. Scientists still aren't entirely sure why the corona is so hot, but it's one of the Sun's biggest mysteries. Sometimes the Sun shoots out violent bursts of energy called solar flares, or even more intense eruptions called coronal mass ejections (CMS), which hurl billions of tons of plasma into space. When these reach Earth, they can disrupt satellites, power grids, and even cause auroras, those beautiful lights seen near the poles. You've also got sunspots, which are cooler, darker areas caused by intense magnetic activity. These spots can be larger than Earth itself and often appear in cycles that last about 11 years, where the Sun's activity increases and decreases. This solar cycle affects space weather and can even impact our climate slightly. And eventually, about 5 billion years from now, the Sun will run out of hydrogen fuel. When that happens, it'll expand into a red giant, likely engulfing Mercury and Venus and maybe even Earth. After that, it'll shed its outer layers and shrink into a white dwarf, leaving behind a glowing shell of gas called a planetary nebula. Even in death, the Sun will be stunning. The Sun's influence stretches far beyond just providing light and warmth. It's the gravitational anchor of the entire solar system, holding all 8 planets, over 200 moons, millions of asteroids, and countless comets in stable orbits. Without its massive gravitational pull, the solar system would unravel completely. But gravity is just part of the picture. The Sun also constantly emits a stream of charged particles known as the solar wind, which flows out in all directions at speeds up to 1 million miles per hour. This solar wind shapes the heliosphere, a massive bubble surrounding the entire solar system, acting as a shield that protects us from harmful cosmic radiation. It even creates a boundary in deep space where the solar wind collides with interstellar space. This area is called the termination shock and was crossed by Voyager 1 in 2004. When the solar wind interacts with Earth's magnetic field, it can trigger powerful geomagnetic storms, which sometimes mess with our satellites and communications, but also create the glowing auroras seen near the poles, Aurora Borealis in the north and Aurora Australis in the south. The amount of energy the Sun produces is nearly unimaginable every second. It generates more energy than all of humanity has used in its entire history. In fact, just 1 hour of sunlight that hits Earth is enough to power the entire planet's energy needs for a full year, if we could capture it all. That's why solar energy is such a huge focus for the future of clean power. The sunlight we see is only a small part of the electromagnetic radiation the Sun gives off. It also emits infrared, ultraviolet, X-rays, and radio waves, most of which our atmosphere filters out to protect life on Earth. Our ozone layer, for example, blocks much of the Sun's harmful UV radiation, preventing deadly damage to living cells. And while the Sun seems like an eternal presence, it actually had a beginning. It formed about 4.6 billion years ago from the collapse of a massive cloud of gas and dust. As gravity pulled the cloud tighter, the center heated up and eventually ignited into the nuclear fusion that powers the Sun today. The leftover material from that collapse became the planets, moons, and other objects orbiting it. In this way, you could say everything in the solar system, including us, was born from the same cloud as the Sun. Even the elements in our bodies were forged in stars like the Sun. The carbon in your cells, the oxygen you breathe, and the calcium in your bones all originated from nuclear fusion in stars, then spread through the galaxy by supernova explosions. That means, in the most literal sense, we are made of star stuff and the Sun is our cosmic sibling and life giver. Culturally, the Sun has been worshipped and revered for thousands of years. Ancient civilizations like the Egyptians, Aztecs, Hindus, and Greeks built temples and myths around it. They saw it as a god, a chariot, a firebird, a life force. And they weren't wrong.